So now what I'm discussing about history of Unix. So now up to now we discussed about Linux. Why now history of Unix means because Linux came from Unix source code. Linux came from Unix source code. Unix source code is open to everyone. Using Unix source code, anyone can release their own operating system. Using Unix source code, anyone can release their own operating system. And as a fresher, you're going for any interviews. In some interviews, they may ask you who invented Unix, who invented Linux, this type of questions. So that is the reason the screen is here. Okay. So first started Multics. So in 1965 by AT&T, then it came to later they released it as Unix in who invented means Ken Thomas in 1969. Then they developed Unix with C language 100% in 1973. In the year 1973, Unix came with 100% C language. Okay. And these are the flavors of Unix, not only Linux operating system. We have different operating systems, okay, who are using Unix source code and released. See, Red Hat introduced Linux. Using Unix source code, Red Hat introduced Linux. Similarly, these are the vendors who introduced their own operating system, like AT&T, Swiss 3, Swiss 4. As Sun, they are using Solaris. IBM is using AX. Still, if you see in IBM internally servers, they'll use AX servers only. So these are the vendors and these are the operating systems who are using Unix as source code. Okay, so source code is same. Only they will do small changes. They will change the view of operating system and they release this operating system. Okay, and here all the operating systems almost work same only. And one more thing is, in interviews, no one will ask you about this vendors and operating systems like flavors of operating systems. No one will ask you. This is only for your idea purpose. That's it, your knowledge purpose. And now history of Linux. Linus Torvald is the graduate student who introduced this Linux operating system in 1990. And he gave this operating system to Open Source Foundation Organization, OSF organization. And these are the Linux distributions. Not only Red Hat Linux, we have different distributors in Linux. So these are the distributors of Linux operating system. Like router means we have routers, right? Routers means not only Cisco routers. We have D-Link, LinkSwitch, Juniper, different vendors. Purpose of router is same, but vendors we have different. Routers, switches, this all same like that. So Linux distributions are this all. We also have Kali Linux. It is not mentioned in this list. Kali Linux, it is also called Hackers Linux. And these are the versions of Linux operating system. In Windows also, we have versions like different versions are there. In servers means NT 2000, 2003, 2008, 2012, 2016, we have different versions. In clients means 95, 98, ME, XP, Vista, Windows 7, Windows 8, Windows 10, Windows 11 versions we have, right? So from one version to another version, they will do some modifications, they'll add some features or they will change the view, something changes they will do and they will release. Same like that here also. We have versions in Linux and two types of versions, free editions and commercial editions. Starting, they released only free editions. From 2003 onwards, they started releasing commercial editions also. Okay, so what is the difference between this free edition and commercial edition? Whether it is free edition or commercial editions, operating system is free only. In free edition, operating system is free in all the versions. And coming to commercial editions, here also operating system is free, open to everyone. Everyone can install commercial editions. Then, what is the difference between free edition and commercial edition? Means for commercial editions, Red Hat gives technical support. You'll get technical support from Red Hat also if there is any issues with your servers or something problem. So Red Hat will give technical support on it. But they'll charge, that is not free, they'll charge for the technical support. Okay, so these are the free editions and commercial editions we have in Linux. Next, features of Linux. This we already discussed, right? So open source code we get along with the operating system. We discussed already these points. And multiple tasks it can do. Multiple users can log in at a time and can be installed in all hardware architecture. We don't require any specific hardware environment. It works with any hardware architecture. And it works with least hardware environment also. We already discussed about this. I'm just re-explaining. Scalability. Scalability means can be installed in all operating systems. It can be used in client operating systems. There is no separate operating systems like client and servers from normal desktop PC to supercomputer. Operating system is same here. So reliability because no downtime. Without restarting the computer, we can update everything. And next security. Security means why Linux is secure means inbuilt IP tables are there means firewalls. And SC Linux is there. IP tables are used to secure networking files. SC Linux is used to secure local files. And it works with command line interface. Those who know the commands, they only can configure something in your computer. So it works with command line interface. And for every user, password authentication is compulsory. For every user, password authentication is compulsory. It means without password, we cannot log in into our computer. Okay. And we can encrypt a file by assigning password. Password encryption is possible here. And it doesn't support exe files. Many PCs are infecting with virus because of exe files only. Linux is not supporting that exe files. It doesn't support exe files. And in Linux, there is no setup. Everything you'll get as a configuration files. Like, so these are the few reasons why Linux is fast. And performance wise, comparing to Windows, Linux is fast because in Linux inbuilt swap option is there. By installing the operating system, creation of swap partition is compulsory. So what is swap memory means? It is a virtual memory which is used to increase the speed of RAM. There is a concept of swap. Swap means virtual memory. Okay, so physical memory means what? Which we can touch physically and we can store the data. Virtual memory means we cannot touch physically, but we can store the data. So in Linux, we can create virtual memory also. Okay, and that space from where we create means from hard disk. We'll create a virtual memory. We'll take the space from hard disk and we'll create a virtual memory. So we can create virtual memory and we can add that space to physical memory. So for example, if your RAM is 1 GB, you can create 2 GB virtual memory and you can add that space to your RAM. So if your RAM is 1 GB, you're adding 2 GB means total size is 3 GB. So your RAM works with 3 GB space while sending the data and receiving the data. So performance, it increases. Also another reason, it works with command line interface. So no need more graphics. So processor works fast. So that is also one reason why Linux is faster. About virtual memory, we'll discuss separately. We have that session also for that. That is the reason not explained completely. And there is a kernel which is interface between shell and hardware. In Linux, kernel is there, which is interface between shell and hardware. So whenever user is sending any data, shell converts the data into zeros and ones. It will not check what data we are sending. It just converts the data into zeros and ones and it transfers to hardware environment, kernel. Then what kernel will do is, before transferring the data to hardware environment, first kernel checks whether the data is supported by hardware or not. See, when you connected a pen drive, if the pen drive is infected with virus, shell convert that virus into zeros and ones and it transfers to hardware environment because shell work is converting into zeros and ones. If something data is coming, exe files are coming, that files are infected with virus, still it converts the data into zeros and ones and it transfers to kernel. If some application you are installing which are not supported by your hardware environment, shell will not check that. Just it converts into zeros and ones and it transfers to kernel. But what this kernel will do, before transferring the data to hardware environment, first it will check the data. Okay, something virus is coming, it rejects back. So pen drive is infected with virus, the data is coming inside, it rejects back. If some applications are coming which are not supported by hardware environment, it rejects back. If super user authentication is there, not there, super user permission is not there, it rejects back. Okay, so before transferring the data, kernel checks everything. That is why, that is also the reason why Linux is secure, and we can also say Linux free from virus. Because of kernel, Linux is free from virus because before transferring the data, kernel is checking everything. So if PCs are infected, some data is infected with virus, definitely it rejects back. So that is why Linux machines are free from virus. So these are the few reasons why Linux wins. These all points we'll see practically also in our classes. This we already discussed. That is the reason not discussed more. And this is the minimum hardware requirement in Linux. So we need 512 MB RAM minimum, 10 GB hard disk is there also. We can install Linux operating system. CLI means command line interface, GUI means graphical user interface. Okay, so it works with minimum 512 MB RAM if you are using command line interface. If you want graphical user interface also means 1 GB is required. In 512 MB also it works with 1 GB, but the recommended 1 GB. And the hard disk minimum 10 GB, maximum and for command line interface, and for graphical user interface minimum 15 GB. This is recommended size. And these are the recommended partitions in Linux. You know this all right, /boot /, you know this all right. These are the recommended partitions in Linux. Okay. Recommended partition means they are not compulsory to install. Okay, they are recommended. Then, what are the recommended partitions in Linux? So, these are the recommended partitions, right? Compulsory partitions in Linux is forward slash and swap. Forward slash and swap are the compulsory partitions in Linux. Forward slash is compulsory because it is a primary partition. You know, right? Why forward slash is compulsory means because it is a primary partition. So without forward slash, there is no subdirectories. Without forward slash, there is no operating system. In Linux, we have C drive, right? C drive is compulsory partition in Linux. Sorry, Windows. Same like that. In Linux, forward slash is compulsory partition. And one more compulsory partition is swap. Swap is compulsory partition in Linux. What is swap? Swap is a virtual memory. I'm repeating, forward slash is compulsory partition because forward slash is a primary partition in Linux. Under forward slash only we have subdirectories. Right. So that is compulsory partition. The size is 10 GB recommended. And next compulsory partition is swap. What is swap? It is a virtual memory. There are two types of memories, physical memory, virtual memory. Physical memory. Memory means what? Storage device. Physical memory means what? We can store the data and we can touch them physically. Like RAM, ROM, hard disk, CD, DVD. These are physical memories. There we store the data, we can touch them physically. Logical memory, virtual memory. Swap is a virtual memory because swap is used to store the data, but we cannot touch swap physically. We create swap partition. We create swap memory from hard disk. Virtually, logically we create. Physically we cannot touch swap memory. Logically we create it using hard disk space. Okay, and that space we add to our physical memory RAM. So for example, if you created virtual memory with 2 GB space, that space you will add to, after creating, that space will add to RAM. Now, if your RAM is 1 GB, what it will do? Using 1 GB space, it can receive the data, it can transfer the data using 1 GB. 1 GB space, 1 GB of data, it will receive at a time. Right. If you have swap memory and that swap memory is added to RAM means 1 plus 2, 3 GB. So using 3 GB, it sends the data, it receives the data. So definitely your working speed will increase. So swap memory is compulsory partition while installing the operating system. And after entering to the operating system also, we create this swap memory. Swap is twice the RAM, double of the RAM. Okay, so after entering to while installing the operating system, how to create, we'll see while doing installation practical. And after entering to the operating system also, we can create swap memory. So that how to create, we'll see in further sessions. It will take almost 1 week time, 1 week or 10 days time. Okay, so forward slash and swap are the compulsory partitions in Linux, and remaining are recommended, not compulsory. So slash boot is recommended. It's not compulsory partition. It is used to avoid wastage. See, slash boot minimum 200 to 500 space is enough because it contains only bootable files. So what we will do is we'll fix the space between 200 to 500 MB so that others will not store any data in slash boot because slash boot contains bootable files. Right. So if others are trying to create something files, personal data, if we are creating in slash boot means what it will do, while booting, it will load that files also, that personal data also. It will check for that personal data also for bootable files. That is waste of time. That is the reason what we do is we'll give less space to slash boot so that no one will store data in slash boot. That is why it is recommended. And slash home also recommended in client pieces. Generally, slash home also recommended directory only. It is not compulsory partition. Why it is recommended to create while installing the operating system means slash home. What it contains? User directories, right? Slash home contains user directories. So when user is logged in, user is storing any data. So that data is going to store under home only. Okay. So if 10 GB we give to forward slash. We don't created home separately. We created forward slash with 10 GB space. So that space only it uses for all the directories. All the directories are under forward slash, right? For all the directories will use the space from forward slash only. Now, already forward slash is using 8 GB, assume 8 GB space it is using for operating system. Remaining space is 2 GB only. So that 2 GB space only it uses for remaining directories. Now, when users are trying to store the data, they can store the data using 2 GB of space only because there is only 2 GB space in forward slash and home is under forward slash, right? So if you want to store more data, you cannot store. So in real time, what we do is we will create separately home directory and we'll give the space like 100 GB, 200 GB or 500 GB depends on number of users logging into that particular machine. Based on that, we'll give the space to home directory so that users can use that space. When users are storing something data, it uses the space from slash home. Okay. No, you're not using users. This is your own laptop or desktop. There is no separate users. In that scenario, no need to use separate space to slash home. You can give more space to forward slash only. Because when you are going to log in as a super user, the data is going to store in root, right, which is under forward slash. So no need to give special space to home. So that is also recommended only. Next one is slash USR and slash var. These two are recommended in server machines. Slash USR contains default applications, right? In servers, what they will do is they will give space to slash USR. Separate space they will give to slash USR so that your default applications will run without any interruption. And next one is var. Var contains variable files, means system log files are stored under var. So this also separately they will create. In real time, will create slash var also separately. For maintaining all the users log files. Log files are very, very important in real time. In every company, they will create slash var. Okay, so that it will keep all the user updates into that var directory. Log files. How many users are logged in? Which user logged in at what time? They logged at what time? And what process they did? How much CPU, how much RAM they use? Every information it stores in it. So to maintain that information for troubleshooting, it is required. To maintain that information, we create in server PC slash var. It is recommended in server PC. See, in client PCs, we don't run default applications. So it is not required in our client PCs. So these are the recommended partitions we have in Linux. Forward slash and swap are the compulsory partitions. Among this all, forward slash and swap are the compulsory partitions. And next, slash boot is recommended to avoid wastage space. /home is recommended to store users' data separately. /usr and /var are recommended in server PCs only. So these are the recommended partitions we have. And in interviews, they'll ask what are the compulsory partitions. Remember, // and swap are the compulsory partitions in Linux. File system hierarchy, you know this. So these are the directories we have in Linux, right? So // is a parent directory or top level directory in Linux. And it is similar to C in Windows. And // these are the subdirectories. Root is the home directory for super user. As a super user, you logged in into your computer and you're creating any files or directories. The data is going to store under root. And super user means what? Administrator, remember. Super user means administrator. Home is the home directory for normal user. As a normal user, you logged in into computer and you're creating any files or directories, the data is going to store under home. And boot contains bootable files and kernel up to RHEL6 version.
Ma'am, 1 minute.
Yeah.
Ma'am, which partition is compulsory?
/ and swap.
Okay.
/ is compulsory because it is a primary partition. Swap is compulsory. It is used to increase the speed of RAM. The two are compulsory. / and swap. Clear, Mohanty?
Yes, ma'am.
Done. So boot contains bootable files and kernel. Kernel up to RHEL6 version. Has been contains super user commands, means the commands which can be executed by super user. Bin contains normal user commands, the commands which can be executed by normal user. USR contains default applications, applications which comes along with operating system. Where contains system log files. It is like task manager. Dev contains devices information, means partitions information. etc contains configuration files. System configuration files are stored under etc. OPT contains optional applications. Applications which we install manually. They are not compulsory to install. If we require, we install them. So that type of applications are stored under OPT. Media contains external devices information, like external devices like external hard disks, DVD writers, pen drives, means USB devices. Information is stored in media up to RHEL 6 version. Media contains external devices information. And next one is MNT. MNT contains which partition is mounted with which directory. That information is maintained by MNT. What is this mounting? That I'll show you practically, you'll understand at that time. And run, it contains external devices information and kernel information from version 7 onwards. Kernel is maintained in boot up to 6 version, and external devices are stored under media up to 6 version. From 7 version onwards, external devices and media is stored under run. So these are the directories we have in Linux, which all the directories comes under / only. These are the default directories. These directories also we use in regular classes daily. So at the time, more you will understand about these directories also. Okay. And next is installing the operating system. How to install the operating system, that I'll show in tomorrow's session. Once installation practical is started, daily labs will be there. Okay, regularly labs will be there. So tomorrow I'll show you how to install Linux operating system. Okay, so this is about today's session. We'll meet tomorrow. Thank you for the session. Any doubts you can ask me, or you can end the session. Thank you.
Hello, ma'am.
Yeah, Mohanty.
Hello.
Yeah, Kumar.
This is Vinod, ma'am. Actually, can you tell the how we get the incidents in real time?
How?
How we get the real time incidents in if suppose I was 2 years I put the 2 years experience. Uh, how we get the incidents? Can you tell?
Yes, yes. While explaining the topics, I will explain that also.
I mean, I'm asking real time scenarios.
Yes, yes, that's what I'm telling.
Yes.
While topics explanation, I will give that scenarios also.
Okay. Thank you.
So if I'm giving explanation about something we editor, how we use it in real time, that also I'll explain. Like servers we are using, what type of errors you will get, how to troubleshoot it, that I'll show.
Okay.
Yeah. Anything else?